Welcome to the methods section of text analysis. And in this lecture, what I'm going to go through is a very brief overview of what text analysis actually does, from pre-processing data to applying statistical analysis to the data. And then I'm going to also give you an example. As with all of the presentations, what we do is we draw heavily from standing on the shoulders of giants. Some of the ideas are highlighted as you see in this initial slide, and we'll also provide you resources to go to later and take a look. So what we're interested in doing here is looking at the statistical qualities of the text. What we're trying to do is we're trying to develop an approach to thinking about the organizational structure of text, turning text into data. So when you're thinking about turning text into data, what you're really doing is, okay, what are the statistical properties of text that we want to analyze? So obviously, if you stand back for a minute and think about the way in which text is structured, it has different lengths of sentences. Some sentences are short, some sentences are long. You've got different lengths of documents, and then you've got different size of the body of documents, each individual group of documents, which is called a corpus, and multiple sets of those documents, which are called corpora. So the other statistical property that we can take a look at is the frequency with which a particular term shows up. That's going to provide us some indicator that this document is about X. We're going to take a look at how often a document shows up, and then we're also going to look at how often a term co-occurs. So in a simple case, we might want to say White House or San Francisco. Those terms co-occur. But then when you're trying to describe what the document is about, if I see White House and election, then I might make an inference that what this is about politics. So the statistical properties of the text come about from, thinking hard about what the analytical approach should be. And so what we're going to do is we're going to walk through the moving parts that I just described. So what we're interested in doing is, first of all, like anything, any analytical approach, and this is obviously a data analytics class, how are we going to turn what is largely unstructured information into something that can be turned into an analytical corpus? And so I'm going to spend a little bit of time talking about that, but obviously a lot of the information is in the textbook chapter, which is I like all the chapters in the book. This one's a very nice one. What you'll see here is essentially what we're going to try and do is we're going to take all the information that is embodied in a document or in an email or in a piece of text. We're going to pre-process it. Then what we're going to do is we're going to do analysis. We're going to do a very specific type of analysis here, which is called topic modeling, because it's intuitive and easy to understand, but there are many, many ways of doing it. Machine learning is obviously one of the most valuable ways in which you can classify and cluster information. And then obviously the evaluation piece is an important one as well. So what do we mean by pre-processing data? The biggest thing is to try and decompose your document and the words in the document into its constituent parts. So what you're really trying to do is you're trying to split out the sentences or the words and the strings. In this lecture, all I'm going to talk about is separating out individual words, but quite often what you'll have is what's called n-grams. The bigram that I talked about before is White House. That's a bigram because there's two. San Francisco, that's a bigram. Here we're just going to separate it out, but you can think through how that might be structured. A lot of challenges here. Data quality can be quite low, particularly when you've got social media, when you've got a lot of emojis and you've got a lot of extraneous text that you want to take out, and you've got to make a lot of decisions. As with anything, the devil's in the details. But essentially, the processing, as I said before, is you've got to pre-process. I'm not going to talk about this in this lecture because it's too much, but you can also add linguistic features. You know something about whether it's a verb, whether it's a noun, whether it's a preposition, and so on. And then what you want to do is you want to convert that to a matrix that can be analyzed and then do the analysis. I'm going to say this sounds pretty straightforward, but really such a lot of thinking went into this. And when I first got interested in this work in the early 2000s, when I went to the National Science Foundation, I became convinced that in particular, the text analysis was going to transform the way in which we did policy and social science research. And it was really the work that was being done here that was absolutely mind-blowing at the time. Let me get very specific. This was the time when the Enron scandal hit, and what you had to do was you had to figure out how can you show that there was fraud that was taking place. And what they did was they used text analysis to look at millions of emails, which no human being could have processed. But they were able to take the Enron corpus and look at the interaction between people and the words that were being said, pick that up and make a case. And I don't think that would have been possible prior to the computational techniques that we currently have. So let me get very specific, and I'm going to use examples that Evgeny Kluchikin and Jordan Boyd-Graber, who wrote the chapter in the book, have used in presentations. So the first piece is what's called tokenization, breaking out a document into its constituent parts. And the particular example comes from an abstract, and you can see what we're doing here is really using the spaces between the words to parse out the into separate constituents. You'll see here how with the cease regulatory elements, we are saying that that is one word, and you can see how hard it can be to separate out different pieces. But essentially, you're just taking the space between words and saying that that delimits the entities, the individual entities in the text. So that's called tokenization. Then what you want to do is you want to get rid of what's called stop words. So what do we mean by that? Well, if you think about this, the word the, of, how, and, those are junk words. I mean, they're important to provide context to the reader, but in terms of trying to understand what the semantic context of the text is, they turn out to be, they're in every document. You can't pull out enough information to make it useful. So what you want to do is you want to get rid of them. Now, stop words, by the way, can be corpus specific. So you'll see in this particular document, gene, G-E-N-E, is retained and not considered a stop word. Now, it turns out that when we were dealing with NSF and NIH abstracts, in NIH, the word gene shows up in tons and tons, the vast majority of abstracts. So it really turns into a stop word because it's so ubiquitous. When it came to NSF, however, the gene was the word gene was actually a very useful word because it enabled us to separate out, for example, abstracts that went to bio, the life sciences directorate, versus ones that went to the engineering or to computer and information science and engineering or to math, physical sciences. So the stop words tend to be corpus specific. So you can see we've now reduced it. Now the next thing is to use normalization or stemming. So you'll see here that is the word element different from element? Is understanding different from understand? So what you do here is you strip each word down to its fundamental element. And the reason you want to do that, so you'll see that here understand turns into the same word, element turns into one word, and so on. The reason that you want to do that is essentially the way in which you're going to characterize each document is by the frequency with which individual words show up. So the statistical process here, at least when you're thinking about topic modeling, which is where we're heading, you take all the words in the document, you standardize them, you normalize them, and then you do a frequency count of those words. In more sophisticated techniques, you see how they co-occur and so on. But the most simple way is just to say, okay, the word genome shows up a lot, the word sequencing shows up a lot, the word DNA shows up a lot. So therefore, I'm going to say that this is about sequencing the human genome. So you use the frequency of a word. In order to do that, you need to make sure that the word is standardized, because otherwise understand and understanding are going to show up as different entities and be discounted. So in summary, we think it's very important, just like any data exercise, is to make sure that your data processing is done correctly. The techniques are going to differ depending on the properties. You think about what you're going to learn. There's a lot of good toolkits out there. So now what we want to do is we want to talk about the key concepts. And so again, we're dealing now with this body of text. We want to think about how are we going to characterize these texts, the information in those texts in a statistical way. So one thing, one of the most important concepts is what's called the TF-IDF. And here what we're going to look at is the term frequency. So we're going to look at the word count divided by the number of words in the document. So essentially, it is saying that if I have a word that shows up 10 times in a 100-word email, it's a pretty good sense that that's an important term. If I have a word that shows up 10 times in a 1,000-word document, it's less important. So it's just normalizing. You've got this notion that the frequency with which a term shows up is a signal that that's an important word, but then you have to normalize by the relative importance. Then what we're interested in is the inverse document frequency. So remember I talked about stop words earlier. The was not a particularly useful word, and is not a particularly useful word. It doesn't have a whole lot of discriminatory power because it shows up in every single document. So what essentially this is saying is how important is this in separating out documents from each other? So we're thinking about this in terms of classification, and then what we want to do is just adjust for that. So that TF-IDF is very important. So when we try and figure out this TF-IDF score, we take our abstract that we were talking about before, the key terms, the key words that characterize this particular abstract are listed on the right-hand side. Another way of thinking about text is simply as a bag of words and thinking about the terms that show up as a digital signature. So in this situation, what you can think of is I've got a corpus. I figure out all the words that are in that corpus, and that could be 1 million words. And then what I want to do is I want to say, I'm going to assign those 1 million words a number 1 through 1 million. And then I'm going to, for each document, I'm going to say how frequently does each one of those words show up in the document. And so If you take a look at this abstract to the left, I show the frequency of each one of those words, and that's its digital signature. And that's actually a really important approach as well. So, going a little bit more into the technical aspect here, the challenge obviously is, unlike a lot of different statistical data sets that we think about, text is super high dimensional, right? I just talked about 1 million, and it's quite sparse. It's unusual to have a single document where you have 1 million words show up. Typically, there'll be a subset. So if you think of a matrix where we have a document which is W word long, and you've got each word is drawn from a vocabulary defined by the corpus of P, then the representation of those documents is P times W. And obviously, you could do a simple calculation to see how many ways that can be represented. So what we typically do is we represent the raw text as a numerical array. We map it to the predicted values that we're interested in, if we're interested in doing the work for classification purposes. And then we can use that in subsequent analysis so that we can predict what's going on. So let me go very specifically into one of the most well-known of text analysis techniques, which is topic modeling. And you know, here's the challenge. We ran into this when I was working at NSF. There are 200,000 proposals, and what you're interested in is trying to figure out what is the content of those proposals. It's not particularly reasonable to have to read 200,000 proposals, so how can you do the classification? Now, what we did, this is a good 10 years ago now, is we used topic modeling. We brought 10 teams of experts in and tried to group the proposals in different ways. They tried different approaches. The one that attracted the attention of the NSF program officers is a useful approach, at least to get a first understanding of what was the research that was being done in those 200,000 proposals, was topic modeling. So I'm going to walk through this a little bit. It's also conceptually pretty straightforward, although it can be quite technically challenging to do. So what I like about topic modeling is there's a storyline behind it. There's a conceptual framework about the data generating model. So essentially the basic idea here is, in this corpus, there are a set of latent variables that we're interested in understanding. And what you're trying to do is you're trying to uncover those latent variables. So as you're writing the words in each one of the documents in this corpus, what you're trying to do is you've got these underlying topics that are behind you in your head, and you are translating those into the words in each document. Then the question is simply, how do I use those documents to uncover those latent variables? So the notion of latent variables is very common in social science, very common in policy. This should be a reasonably well understood concept to you guys. So what our statistical inference task is filling in those missing pieces. So let's be very specific. You obviously have to start with saying, how many topics are there? So that's one of the drawbacks. You have to arbitrarily set what K is. In my example of 200,000 NSF abstract, oh, sorry, they were full text proposals because we had internal access. We tried different numbers of buckets. 500 turned out to be too coarse. 1,500 seemed to be too granular. And so we ended up choosing about 1,000 topics. So you're going to take a corpus. And now what I'm going to walk through is an example that Jordan Boyd-Graber put together. And we're going to say there are 3 topics. And as you can see, it's called a bag of words because it's got a string associated with pulling out the key words in each one of these documents. And the first topic is pretty much about IT. The second one is business, retail. The third one is entertainment media. So the topics themselves don't come pre-labeled. Human beings have to curate the labeling, but just looking at it, that seems to be about right. So if you think about the topics as being disjoint, which is one of the goals of having the topics being quite separate. Topic one, which is IT, we have a document that talks about red light, green light, LED. Clearly that document's pretty squarely in the IT bucket. The a document that's called stock trades, a better deal for investors isn't simple, that's pretty clearly in the business bucket. A document that says a peaceful crew puts Muppets where its mouth is, that's clearly in the media entertainment bucket. But then one of the great things about topic modeling is if you think about the underlying latent variable, you obviously have multiple topics that could be incorporated into one document. And this is a massive advantage of having electronic documents. When we only had physical books, an information scientist or a librarian had to put like a Dewey Decimal number and put it, or a classification number, and put it in a physical shelf. Here we can have multiple facets associated with the document, and you can tag them and electronically pull out documents that have multiple topics. So for example, in this orange one, it says the 3 big internet portals begin to distinguish themselves among themselves as shopping malls. So that's clearly in between IT and business. So it has 2 topics in it, and so on. So I'm not going to go through that in more detail, but you get the point. It turns out, and if we were teaching this as a longer course, this underlying this is exactly a graph model. So when you get a chance to do a longer course, you can learn a little bit about that. So here's what we did with the, this is straight out actually out of the, looking at the 200,000 NSF research proposals. What you were able to do is to take a look at the string of words, the bag of words, and then NSF program officers labeled that string of words with what they thought that the topic was that was underlying it. So now what we're interested in doing is, how do you do that characterization? How do you identify those topics? So really what you want to do is you want to be able to separate out your topics in reasonable ways. And the method that's most heavily used in topic modeling is something called Gibbs sampling. I'm not going to go to that in any great detail because, again, this is just a short overview class. But essentially what the Gibbs sampling methodology does is it says, we're interested in the topic assignment of a word N in document D, and there are K topics, and we are going to characterize the topic and a document into a topic by how much does the document like the topic and how much does the topic like the word. You can see this is cut and pasted out of the textbook. So I'm just highlighting it as the key measure that you're going to want to go and take a look at. So unpacking that, that measure, you can think about this as the number of times a document uses a topic in the numerator, then the number of times a topic uses a word. So you could go back and take a look at the examples that I used before, but you can characterize it that way. Then what you're estimating is the Dirichlet parameter for assigning documents to topics, a Dirichlet parameter for topics to words, and then what you're incorporating is how much this document likes a particular topic and how much the topic likes the word. So intuitively, it's nicely unpacked. I don't expect you to understand the algebra in this particular case. I just want you to get the the core notions here. That's what gets you the bag of words. So the point of this video has been to introduce you to the notion of text pre-processing, then walk you through the statistical framework that gets generated, and then give you a particular example based on topic modeling. And there's a bunch of reading that you could do. This didn't do justice to what I think is a fascinating area for you to look at. And go ahead and take a look at the example in actually paper 3 for this section on the website. Thank you very much for paying attention.